Okay, hi guys, welcome to class. So you are in class 2, which is being taught by me and then Amy. So,
And
oh,
well, just one more thing. And our topic today is just going to be exponents, radicals, and logarithms. But this, even though it's just for this, even though like today's topic is exponents, radicals, and logarithms, we're going to have more of a focus on exponents and radicals. And then next week, we'll actually continue this topic and go into about what logarithms are.
yep.
Yeah, you can turn on your cameras if you want to, but you don't have to.
So just for an introduction, so I think most of you guys know what this course is, but just in case. So this course is a math course and it focuses on teaching topics that will help you prepare for math counts. So I think like most of you said you were from Mazik. So you probably know what math counts is, but math counts is basically a math competition for middle schoolers only. And it has 4 levels, which is school, which is just at your school level, chapter, which is Louisville, state, Kentucky, and then nationals. And the lessons throughout this course will also be useful in any other math competitions, such as AMC, and they can give you a head start in your school classes. So I said earlier, but my name is Kayang. I'm one of your teachers. And a fun fact about me is that I did math counts all 3 years of middle school.
Yeah, and my name is Amy. I'm also going to be teaching you for this next few weeks. And a fun fact about me is that I only did math counts 2 years in middle school, but I got second place at state, and it was cool.
Oh yeah, oh by the way, we're both in 10th grade now at Manual.
Yeah. Okay, so now we're going to go over some things about this class. So I think probably the most important thing about this class is that you should definitely expect to be challenged. So there are probably going to be some things in this class that you might not understand at first, or that might make you a little bit confused. So don't be afraid to ask questions, because that's how people learn. And that's how questions are important, and you can just ask us whenever you have them. And second thing is there will be homework. But the thing is, I don't think a lot of people like doing homework all the time. But so we're going to be doing it through like quizzes, where you can sort of compete with like your peers, your classmates, but also sort of just like reviewing what we taught in class. And that's usually going to be posted like after class or something. And we're going to be doing a class ranking system. Basically, it's like standings. Every week, we're going to be posting like the top 5 people who have the most points. Oh, and for the person in the chat asking about quizzes, do you know what Kahoot is? It's sort of like Kahoot. Like it has like it gives you questions, but it doesn't exactly happen at this. Yeah, it's not synchronous. And they give you some stuff like power-ups and bonuses, and they also let you like re-answer questions that you missed. But yeah, it's a little bit different than Kahoot, but it's similar.
Mm-hmm. And classes are on Sundays, yes.
Yeah. Oh yeah, and so we're going to be doing class ranking system. Basically, you guys can like get points for doing stuff. So basically, you can get points for like participating in class. So like you can answer questions in class or ask questions in class. You can also get questions for you can get points for asking questions. You're also going to get points for like doing your homework, like doing those quizzes. And then you can also get points for like getting more questions correct and just doing like other activities throughout the year. So like sometimes we have like in-class competitions, like doing Kahoots in class, or sometimes we might have a countdown round or something. You can get points for doing those activities too. And we're going to be posting the top 5 people with the most points, like at the end of the week or like right before classes. So that's how you can see like who has the points. But we're only going to post the top 5 people though. So yeah.
And I don't think you need to
Yeah,
say
that's
the exact point number, just who's the top. So today we're gonna go over more about exponents and radicals. So 1 second, I need to move something. Okay. And we're gonna go over what exponents are, exponent operations, negative exponents, fractional exponents. And with radicals, we're gonna do properties of radicals, operations, and finally nested radicals.
okay. So this may be a little bit of a review for some of you guys, but we're still just going to go over it because it's pretty important for understanding exponents. So exponents are just like repeated addition, right? So you indicate exponents by writing a little number at the top right of the number of like the larger number. So 5 with a little 8 on the upper right corner, that's 5 raised to the 8th power. And that means there are 8 5s being multiplied together. So 5 times 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 5. Exponents make it so that you don't have to write out each of those individual 5s, and you can just write it by 5 raised to the 8th power. Yeah, whenever you see like a large number and a small number in the corner, that's like a number raised to a power. However, some powers, like some have special names. So 5 raised to the second power is 5 squared. That's 5 times 5. 5 raised to the third power is like 5 cubed. And there's like a visual. We can visualize exponents using like, I guess you could use cubes to help visualize them. So yeah.
Yep. There you go.
There should be a trash can button.
Yeah. Okay. So.
Okay. So you guys. Oh, you can go, Kyle. Sorry.
Oh wait, no. I think it's still yours. Wait, is it me?
Okay.
It's fine. I can do it.
I have no idea.
Okay, so we're gonna go over exponent operations really quickly. So for example, this example question, 2 to the 6th times 2 to the 8th. And when you're multiplying two exponents that have the same base, so the base is the number you're repeatedly multiplying. So like, what did my thing go? It's the 2 right now. This is the base. And since they're the same, we can multiply them by just adding the exponents together. So yeah, somebody said in the chat that it's 2 to the 14th, which is correct. Because if you just add the 6 and the 6 and the 8, you would get 14. And this also makes sense if you write it out, since 2 to the 6 is 2 times 2 times 2 times 2 times 2 times 2. And then 2 to the 8th is 2 times 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 2, which if you just put together, it's 2 times 14 times, yeah. So next we're gonna go over division. And division is pretty simple too. So when you divide two exponents with the same base, so make sure you see that it's the same base, you can just subtract the powers from each other. So for example, this one is 2 to the 8th divided by 2 to the 6th, and you can just subtract the 6 from the 8 to get 2 as your exponent. And we can also see this by writing it out again. So you can see that the numerator has 8 2's multiplied, then the denominator has 6 2's multiplied, and we can just cancel them out to get 2 to the 2 squared. Yeah.
Okay, so now that we've reviewed some basic exponent operations, we're also going to do some very basic variable review, just to make sure everyone is on the same page. So first of all, what is a variable? You guys can like type in the chat, what exactly is a variable? Like if you know, you can just type in what you think it is. If you don't know, just make a guess.
Letter that's like you have to find the number of, or has like, I don't know how to explain, but like it has, the variable has a certain number tied to it.
Yeah.
Yeah, all of the stuff that you guys have put in the chat and what you said. Yeah, variables, it's an unknown number. It stores a number of value. It mostly variables just indicate that there's a number here, but we don't know what it is. So yeah, it's a symbol that represents a value that we don't know. But here's the thing, you can use anything to represent, like, you can use anything as a variable. It doesn't just have to be a letter. You could use a smiley face as a variable if you really wanted to. It's just that we in the math world tend to prefer letters. So yeah, like, since a variable is just a number that we don't know, you can like treat it as a number. Like, you can multiply variables, divide variables, add variables, subtract variables, do whatever you want with a variable. Just know that it's a number that we don't know. So like, it's like a number in disguise. I mean, I guess you could think of it that way. So like, as an example, if we have the question where like we have variables raised to a certain power, so like k raised to the 4th power times k raised to the 7th power, we don't need to know what k means. We just need to know that it's a variable, and a variable is just a number, so we just treat it like a number. Normally, when you multiply when you multiply numbers that have exponents together, you add the exponents, right? So you just do the same thing here. So k to the 4th power times k to the 11th power is just k to the 4th power times k to the 7th power is just k raised to the 11th power. So there's nothing special about it. We just need to know it's a number. So yeah.
Oh, okay, I guess I can do this. So we're just gonna start practicing, and this will most likely be review for all of you, but I think you guys can get points for this.
Yeah.
So we'll do,
Once you've got the answer for something, make sure when you're typing the answer, make sure you include the problem number with it.
yeah. Do you want to do like the first 5 people per problem, Amy, or because I feel like it might be hard to keep track of.
Yeah, sure. Also, please change your Zoom name to your real name, because otherwise, I don't know who you are and I can't give any points for that. So, yeah.
If anybody doesn't know how to change their name, just like if you hover over yourself, there should be 3 dots, and then you can say click rename and type your name. Oh, yeah, so I just said it. Chanel, I think. Is that your name or no? No, okay. So just find yourself like on the Zoom thing, you should see your name. Well, not your name, but the name Chanel. And if you hover over it, there should be a mute button and then a button with 3 dots on it. So if you click the button with 3 dots, one of the options that pop up would be rename, and you can click that to type your actual name. And yes, so you're supposed to be solving these problems right now. We'll reveal the answers in just a second. Oh, oops, nobody saw that. Will we do a Kahoot in class? Today, I'm pretty sure no, right?
Yeah, I don't think there's a Kahoot today.
But we will have them like throughout this year, like this course. Tell me when you get like 5 so that we can go move on. How long is this course? Do you mean like when does it end? Okay, so it ends like when math counts chapter round is, which is like the beginning of 2022. So I think it ends sometime in January.
Yeah, I think it ends January 30th, which is like the week before chapter comp or some math counts competition.
Yeah,
I
I
can't
think
remember quite.
after. Yeah. How long are the classes? So classes are from 3 p.m. to 4:30. So we have about an hour left. Should we go over the answers now?
Sure, you can go over them while I'm updating the points.
Okay. So yeah, I think a bunch of you got the right answer for all of these. But so I'll just quickly go over how to do it. The first one, 5 to the 5th times 5 to the 11th. Since it's multiplication with the same base, we can just add the exponents. So 5 to the exponent of 5 plus 11 is 16. The second one is division, and it's 7 to the 14th power divided by 7 to the 7th. And since the bases are the same, we can subtract. For the third one, we see a variable. So our variable x just represents a number, right? So we can just pretend, we just treat it as a number and do the same thing by subtracting the exponents.
Wait, I was accidentally sending my answers to someone by mistake. So
Oh, that's okay.
you want me to I'll just do them again and I'll make sure I send them to everyone. Okay.
Yeah, that's fine. So that's on number 4. Number 4, 2 to the 4th times 2 to the 6th is just you add the exponents. Then number 5, you subtract the exponents again. Number 6, you add the exponents. And then number 7, this one is a little more tricky since there's actually 2 different numbers involved. But all you need to do is, this is the same thing as x squared times x cubed times y to the 5th. So group this together, x to the 5th times group this together, y to the 6th, and you can get this as your answer. All right. So let's move on.
Okay, so for this problem, we're going to introduce another property of exponents. Essentially, when you have one number raised to another number, and then you raise that one to a third number, you can multiply the exponents together. So, Kayan, could you move forward one step?
Sorry.
Okay, thanks. So yeah, for this problem where it says 2 to the 3rd power, then raised to another power, you would just multiply the 3 and 2 together. So could you move forward one more step? Yeah, so in this case, it would just be, since 2 to the 3rd raised to the 2nd power, then it would just be 2 raised to the 3 times 2 power, which would be 2 to the 6. So you can also see that this works by solving the problem manually. So 2 to the 3rd power is 2 times 2 times 2. So if you square that again, then it would just be 8 squared, which is 64.
Okay, we are going to do a little more practice again. So similar to what we did last time, please label which question you're answering with your answer and just type your answer in the chat. And we will go over it in just a second. Okay, we're gonna wait like 30 more seconds and then go for the answers. Okay, so number one, I'm gonna go over in a little more detail. So we see that this one is 3 squared to the 5th power. So there's two exponents, right? And if I write this out, so I'm gonna pretend I don't see this, like, this is just one number, okay? And if I raise a number to the power of 5, I just multiply it 5 times by itself, right? So 3 squared times 3 squared times 3 squared times 3 squared times 3 squared. So pretend this, you don't see the 2. This is just one number being multiplied by itself 5 times. And now we realize that when we multiply numbers with the same bases, then we can just add the exponents, right? So now we see that the number we multiplied 5 times is 3 squared. So then we can add the exponents and we can get that it's 3 to the 10th power. But we also realize that if I didn't take the long route, yeah, so it's, if you just wrote like 3 to the 10th, that's okay. We don't need you to write out everything. But if I did write out everything, it's just 3 times 3 times 3. Yeah, what Amy put in the chat. So I just can multiply the two exponents together to get 3 to the 10th too. So if you put both, like if you put either what actually 3 to the 10th is or 3 to the 10th, then you're good. So for the second one, using like a similar logic, so x cubed, which is x times x times x, right? Maybe this will be less confusing. So if I have this and I multiply this thing 4 times, like 2, 3, 4, and all of them have 3 x's in it. Then I realized that I can just count how many x's there are and put it as an exponent. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this one is x to the 12th. This third one is similar to the first question. So it would just be 123 to the 18th power times 123 to the 18th power. And I can just add these to get 123 to the 36th power. And finally, this last one may be a little more confusing since it does have some extra steps. So the way it's written, it might look a little weird, but what this is saying is just x squared to the 4th power times y over x. So what is this thing? Well, we need to figure that out first. So x squared to the 4th is x to the 2 times 4 power, which is x to the 8th times y. And now we have to make sure we don't forget about this little x at the bottom. So like this, when I write it out, is x times 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 x. Maybe I said 8. So like 8 x's. And if I cancel out one of them, this will be actually x to the 7th now. So the answer is x to the 7th times y. Does that make sense to everybody? If you have questions or if you're confused about any of them, now would be a good time to ask. Okay, I see people that are saying it makes sense. And if by any chance, like if somebody on here is confused or need me to slow down more, or like you feel like at the end of today's class, you feel like this class might be a little too hard, we can always move you to the other class, which will be a bit easier. So just keep that in mind. No, there we go.
Okay, so so far, like for exponents, we've been raising them to like the first power or the second power or the third power. And just to reiterate, exponents just mean repeated multiplication. So if you're raising something for the second power, you're multiplying it 2 times. And if you're raising something to the fourth power, you're just multiplying it 4 times. But what happens if you raise something to the 0th power? Is that even possible? Okay, so it turns out that you can raise stuff to the 0th power. So basically anything raised to the power of 0 is 1. It's just 1. So like 2 raised to the 0th power is 1, 3 raised to the 0th power is 1, 100 raised to the 0th power is 1. Well, except for 0. 0 raised to the 0 is confusing. Let's not talk about 0 raised to the 0. But for all other numbers in general, if you raise it to the 0th power, it's going to equal 1. So like the reason why it always equals 1, well, we can look at some of our exponent rules. So let's think about 2 raised to the 2nd power divided by 2 raised to the 2nd power. So remember that when you're like dividing exponents with the same base, you can subtract the exponents. So 2 raised to the 2nd power divided by 2 raised to the 2nd power would just equal 2 raised to the 2 minus 2 power, which is just 2 to the 0 power. Oh, hey, that's something raised to the 0 power, right? So, but however, if we actually think about this 2 squared divided by 2 squared, that's just 4 divided by 4, right? And 4 divided by 4 is just 1. So 2 to the 0 equals 1. And yeah, so it's best not to think about it as actually like raising is something to like a 0 power. Just think about that like when you divide 2 things by itself, and they have like the same exponent, they end up becoming a 0 exponent, and that equals 1.
Yep. All right, so next we're going to look at negative exponents. So far we've only looked at exponents that are positive and exponents that are 0, right? But negative exponents are also a thing. So basically up here, there's like a general rule with using variables, which says that x to the negative y power is 1 over x to the y. And I'll explain this. So when the exponent is a negative number, this is saying how many times you should divide 1 by the base. Or in other words, some people said it in the chat, I think the reciprocal, which is correct. So 1 over your number, I guess. So for example, 2 to the negative 2 power is 1 over 2 squared. So in the bottom, make sure you don't put negative 2, just put 2 squared. And yeah, it's pretty simple. So nothing to be scared of. And this just becomes 1/4. And you can also think of it in like steps if it's a little confusing. You first remove the negative sign from the exponent. Then you write 1 as the numerator, which is the number at the top of a fraction. And then write the fraction bar. Then write the exponent and base as the denominator. Then you just solve it. So I'll just give you one more example. Let's see. Oh wait, oops. So let's try 3 to the negative 3 power. So when I do this, so you might not understand like why it's like this, but for now, just try to learn like how you solve it. So this right now, we see that it's a negative exponent, right? Then first we are going to disregard the negative sign and write the number. Then we're gonna put it as the denominator and write 1 at the top. And now we can solve it, which is just 1 over 3, 20, 1 over, 27. That's a 2, by the way. So does that make more sense? Hopefully it does. And if it's too confusing, again, you can stay after and we will talk to you about it. Wait, why can't I move? Oh, there you go.
Okay. So now we're going to take another jump to fractional exponents. So fractional exponents, well, first let's think about what 64 raised to the 1/2. What exactly would that be? So like, how do you raise something to a fractional power? Like if your normal exponents work by multiplying numbers multiple times. So like, for example, 64 to the 2nd power would just be 64 times 64. But what about 64 to the 1/2 power? So basically, the answer 64 to the 1/2 power is just 8. It would not be half of, oh, Kayan, can you move forward one? Yeah, 64 to the 1/2 power would equal 8. It wouldn't equal 32 because that's just regular dividing, but here it's our exponent that's 1/2. So remember the multiplication rule for exponents. 64 raised to the 1/2 times 64 raised to 1/2 equals 64 to the 1st power. Remember, because we add the exponents that have the same base. So if we want to find 64 raised to the 1/2, we just ask ourselves what number multiplied by itself equals 64. So that would be 8. And essentially, that's just the square root of 64. So yes, raising to the 1/2 power is the same as taking the square root. So like x raised to the 1/2 power would just be the square root of x. X raised to 1/3 power would just be the cube root of x, and so on and so forth. So now what about like 64 to like the 3/2 power? Like what does that even mean? Like you're just raising it to random fractions. But here's the thing. We can remember that when we raise a power to a power, you just multiply the powers together. So 64 raised to the 1/3 power would be the same thing as 64 to the 1/2 power raised to the 3rd. Which again, as a reminder, when you raise a power to a power, you just multiply them together. So we can just split that. We can go backwards now and split them apart. So 64 to the 3/2 power would equal 64 to the 1/2 raised to the 3rd power. So from our last slide, we know that 64 to the 1/2 is equal to 8. And now, so we can just replace the 64 to the 1/2 power with 8. So now this just becomes 8 to the 3rd power, which is just 8 times 8 times 8. And that's 512. Okay.
All right. So now we're going to practice. And if you don't completely get it, then that's okay. So we're going to go over these in more detail, so you'll probably understand. And the same thing, just put your answer in the chat and label which one you're answering. We'll give you like, I want to say like 6 minutes-ish, 6 to 8, unless everyone finishes really quickly. Yeah, it doesn't matter if you do it separately or at once. I think I'm gonna wait 1 more minute before I go over it. All right, I'm going to go over them. So starting with number 1, this one is just what we just went over. So this is basically asking what number multiplied by itself equals 25, which basically means what is the square root of 25? And that would be 5, because 5 times 5 equals 25. Oh, that's really messy, but yeah. Number 2 is using the negative exponents. So if you remember, to solve this, I write the 1 as the numerator. Then I take my base and my exponent without the negative sign and put it at the bottom. So 8 cubed, which is the same thing as 1 over 8 times 8 times 8. Which is 64 times 8 as well. I think. Wait, why did I forget what 8 cubed is? 64, I think. Oh, it's 5. Yeah. Oops, that 6 isn't supposed to be there. It's a 2, guys. Okay, this is like really messy. Sorry. 5, 12. Okay. Yeah. And then number 3 is the kind of harder fraction that we just looked at. And so first we need to realize that this is 100 to the 1/2 power to the 3rd power. And we can see that 100 to the 1/2 power is basically asking the square root of 100, which is 10. And 10 to the 3rd is 10 with 3 zeros, which is 1000. Number 4 is asking for what number multiplied by itself 4 times is 256. So it's kind of similar to the square root, but this is, I guess, the 4th root. So if we kind of want to simplify it, I guess. So 16 times 16 is 256. And then 16, you can break that up into 4 and 4. So if you don't know what the 4th root of 256 is, that's okay. You just need to like go in steps. So we realize that it's just 4. And all the answers will be like neater at the end so you can see. So number 5 is just kind of simple. So you make 1 the numerator, then you add your base and the exponent without the negative sign at the bottom. And 123 to the 1 power is just 123. So I'm going to move this one over here because I don't have any space. So 4 to the negative 1/2 power. So now this one might be a little more confusing, but I'm going to try to deal with the negative exponent first. So to do this, I'm going to write 1 as a numerator and then take the base and my exponent without the negative sign. So now it becomes 1 over 4 to the 1/2 power. So then now I can deal with my 1/2 power. And this is asking for what number multiplied by itself is 4, which is 2. So it simplifies to 1/2. This one goes here. So now this one is also a little confusing. Someone's writing on my screen. So yeah. This one is asking what number multiplied by itself 3 times equals negative 125. Well, we know if we multiply a positive number 3 times, then, well, it's not going to become negative. But a negative number multiplied 3 times, like by itself 3 times, is negative. So we know that 5 times 5 times 5 is 125. So then that means negative 5 times negative 5 times negative 5 is negative 125. Since negative 5 times negative 5 is 25, and then 25 times negative 5 is negative 125. That's hard to say. Now this last one is kind of confusing as well. But so first we're going to look at, kind of work backwards and look at this fraction first. So if we want to think of this denominator in terms of 2, we know that 2 to the 6 is 64. Since 2 times 2 times 2 times 2 times 2 times 2 is 64. We know this, right? So then we know 2 to the 6 is 64. But that's not what we're looking for, and we're looking for 1 over 64. But we can remember that when you have a negative exponent, you make 1 the numerator, right? So then that must mean 2 to the negative 6 is 1 over 64.
Okay. I think now I can ask for questions about the practice, or just questions about anything we've gone over so far. If there's something that doesn't really make sense to you, or you want us to go over again, you can ask. You can tell us, and we'll go over it again before we move on. Okay.
Somebody says, I don't get number 8.
Yeah, negative numbers are just regular numbers, but they have the negative sign in front, which indicates that they're on the other side of the number line.
So I also see I don't get number 7. So 7 and 8. Anybody else with any other question? Okay, so I'll just clear everything. And number 7. So I guess this might be confusing if you don't know like how to deal with finding the roots of negative numbers. But basically, this one, you can just see that like if I don't have this negative in front and I just have 125 to the 1/3 power, I think this should be easier. So what number times itself 3 times equals 125? That's just 5, because 5 cubed is 125. Now, if we put the negative symbol in front, now we're looking for which number cubed is equal to negative 125. Well, the only thing that's changing is the sign, which is like the positive and negative, and the number itself, like the numeric value will really change. So if I do -5 cubed, that's -5 times -5 times -5. And when you multiply a negative number by a negative number, it becomes positive, right? So this is 25. And then if I multiply this by -25, a negative times a positive is negative. So this becomes -125. Does that one make more sense? Yes, okay, thank you, that's good. Oh no. Well, I don't know how to explain it differently than that.
Is there something specific that you're confused about?
Yeah. Like a specific step. Everything.
Do you have you done with negative, have you done multiplying negatives before?
No, okay, that makes sense then. If you, both of you, Brayden and Tanisha, if you could stay like after class for like maybe like 2 minutes, that's probably enough. Then we will talk to you privately.
We can probably, yeah, we can get that figured out.
Mhm. Yeah, that's okay
Okay.
that you don't understand.
Yeah, that's fine.
So number 8, I'll just go over quickly again. So like basically if I didn't have this 1 in the division, and if I just had this, then this is asking for 2 to the what power is equal to 64, right? And well, if you think about it, you can probably figure out that 2 to the 6th power is 64. So if you want to multiply out the 2's, then you will probably realize that it is 64. So, but if I now look at the actual question, which is asking for 1 over 64. Well, in order to make make this number become a reciprocal of itself, I can make the exponent negative, because like when I deal with negative exponents, I take the reciprocal of the number without the negative, right? So then if I do 2 to the -6th power, then that should equal this, because like if I want to look at this and just solve it, I put the 1 at the top and then I put 2 to the 6th at the bottom. Does that make sense?
If a power like or exponent has a negative on it, then that means that it's kind of like square root or whatever, like it divides instead.
So the square root one is like the fractional exponent, like this one, the number 1. But a negative exponent is where you find the reciprocal. So if you don't know what that means, it just means like if I have 2, the reciprocal of it is 1 over 2. If I have -100, the reciprocal of it is 1 over -100. So
Okay,
you
got
just
it.
put it as the denominator and put 1 as the numerator. Hopefully that makes more sense to everybody. All right. Due to time and stuff, yeah.
I think we can probably skip the challenge ones for now, but if we have time at the end, we can come back to it.
Yes, we will come back to it. And you can look at this on your own time if you want to too.
Yeah, we'll be posting like the recording and the slides on the classroom. So if you're like still confused about something or you just want to look back, you can definitely do that. And if you want, you can also ask us questions too.
Yep.
Okay, so now we're going to talk about radicals. Radicals, well, they're related to fractional exponents. So basically, fractional exponent tells you how many, tells you like a number multiplied how many times should equal a number. So radicals are a way to, radicals are pretty cool. another way to write fractional exponents. So this radical here is a square root. And basically square roots are saying, okay, what number multiplied by itself equals the number that's inside itself. So the radicand is the number that's like underneath the radical symbol. And so this expression would be read as the square root of 9. And so this is just saying what number times itself equals 9. That's just 3, because 3 times 3 equals 9. So that's just what the radical is. And you also have cube roots, like this is a square root. This is saying a number multiplied by itself equals another number. A cube root says what number multiplied by itself 3 times equals another number. So in this thing over here the number 3 here just tells you it's this cube root, and it's saying what number multiplied by itself 3 times equals 8. So that's equivalent to 8 raised to the 1/3 power. So this will just be 2, because 2 times 2 times 2 equals 8. Square root of 1 is just 1, because 1 times 1 equals 1. So I don't know why. You mean quartic root? I don't really know why. We just call it the 4th root, maybe because it's too hard to remember all those numbers. Yeah, square root of 1 is 1.
Yep.
Yep.
Okay, so let's go to simplifying radicals. So simplifying just means kind of like solving, right? Until you can't simplify anymore. So right now we're going to practice just some of the more simple radicals. So if you can answer these really quickly, that'd be great. And this one, we're just gonna go over pretty quickly. So I'll wait like maybe 1-2 minutes. And you don't have to answer like all of them, just like a couple of them would be fine. And for number 6, you can just ignore this one.
Yeah, I don't think it's supposed to be the 4th root.
Yeah, I think it's a typo, but we'll just ignore.
Yeah.
Goodbye.
Oh, the check mark is, oh, sorry. The check mark is just a radical or a square root.
Oh, yeah.
It looks like a check mark because keyboards don't let you type square roots the proper way. So yeah, they ended up looking like check marks.
So that's how they're supposed to look. I'm gonna wait 30 more seconds and then go off. All right. So the first one is asking what number times itself is 36. And that is 6, because 6 times 6 is 36. Right. This one, what number times itself is 81. Well, that's just 9 because 9 times 9 is 81. And then this one is what number times itself is 4? Well, we know that 2 squared is 4. So the answer is 2. This fourth one, we are asked for the square root of 169. And we know that 13 times 13 is 169. So the answer is 13. And finally, this last one is asking for the cube root of 27. And so this is asking what number multiplied by itself and then multiplied by itself again is 27. And the answer to that would be 3 because 3 cubed is 27. And that's a 13. It kind of looks like a B. So I think the answers are actually on here too. Yeah. All right. So, and then, well, sometimes the radicand, which is the number that's under the radical, isn't a perfect square or cube. So you can't like find a whole number where you can like square or cube it to find the answer. So when that's the case, like for example, this one that's on the screen, the square root of 24. Well, I don't really know what number times itself is 24. I know 5 times 5 is 25, but I don't know something that I can multiply by itself to get 24. So then when that happens, we're going to do something else. And first, we're going to go over this rule first that will help you. And this rule at the top is saying that, like, if we are asked to find the square root of a number xy, which is x times y, then that is equal to the square root of x times the square root of y. So for example, for this one is in like a different order, but like if I write it in the order that's in the rule, then it's this. So basically, I'm just splitting this one up into the 4 and the 9. And let's see if it works. So the square root of 4 is 2 times the square root of 9 is 3, and that is 6. And if I just look at this one, the square root of 36 is indeed 6. So we know, well, we kind of know that our rule works. So let's assume that our rule is true, and we are going back to the one we, yeah, I'm writing, this is the rule right now. So we're gonna go back to this. Let me reorganize my screen for a bit, I can't see. Okay, so basically, what you're gonna try to do is look for perfect square factors in the radicand. So like 24, I can split up into different numbers, right? Like 1 times 24 is 24, 2 times 12 is 24, 3 times 8 is 24, and so on and so forth. But I'm gonna try to split it up so that at least one of the numbers is a perfect square so that I can factor out things. Yeah. And here I realized that I can split up 24 into 4 and 6. And one of them, 4, is a perfect square. So when I simplify this, I can get to 2 times the square root of 6. And if I simplify, it's just 2 radical 6. Somebody says, what do we call you? You can just call me by my name, which is Kayang. So it's just Ka and then Yang, like the word young. So I think, is this confusing or does this make sense? It's Kai Young, like young as in like a young person or an old person. And then Ka at the beginning. Okay, it makes sense. Yeah, it's like that.
Okay, so now we're going to talk about radical operations. For these, you just treat the radical like a variable or like some other number. So when we're adding radicals, we can only add them if the number under the radicand is the same. So you can add square root of 3 plus square root of 3. That would just be 2 times the square root of 3, because remember, multiplication is just repeated addition. So square root of 3 times square root of 3 is just 2 square root of 3. And by the way, we just wrote the 2 directly next to the square root sign because I guess mathematicians are lazy and decided not to put in the multiplication sign. So that's something that people in math do. They just ignore the multiplication sign and write numbers directly next to each other. So, but don't let you throw that off. Don't let that throw you off. It's just 2 times the square root of 3. So, yeah. And the next one is subtraction, which again, mathematicians decided to drop the multiplication sign. For this one, we subtract the coefficients or the numbers like behind the radical. So 4 square root of 3 minus 3 square root of 3. We just subtract the 4 and 3 from each other, but we keep the square root of 3 because those are the same and we don't do anything with that. You can think of it as using the distributive property to pull the square root of 3 out. So that this becomes just 1 times the square root of 3, and which is we can leave the 1 out. So this just becomes just the square root of 3. So 4 square root of 3 minus 3 square root of 3 is just square root of 3. And the next operation is multiplication. For the multiplication, we would multiply the numbers inside of the radical, and then we would simplify the radical as we normally would when we're trying to pull the perfect squares out. So this would be the square root of 3 times 3, which is the square root of 9. And since the square root of 9 is 3, that is just the answer, 3. Are there questions about these operations? Okay.
Okay. So radicals in the denominator. Technically, there's like nothing completely wrong with it. Like it still makes sense. It's not like undefined or anything. But especially during competitions like math counts, you can't have a radical in the denominator as your final answer, or else it won't be considered simplified. So let's say I'm solving a problem and my answer becomes this. So the radical 32 over radical 6. I can't just write that as my final answer, or they're gonna count it wrong. So now I have to simplify it. So in order to do this, I'm gonna multiply my number by 1. So if I multiply a number by 1, like nothing changes, right? But I can write the number 1 in different ways. So like 2 over 2 is 1. 500 over 500 is also 1. Negative 2.2 over negative 2.2 is also 1. So what you can notice is that a number over itself is 1. So in here, radical 6 over radical 6 is also 1. So when I'm multiplying by this fraction, I'm not actually changing my number by any way, I'm just multiplying it by 1. But conveniently, when I multiply my number by this specific fraction that equals 1, I can get rid of the radical in the denominator. So what I mean by this is going to become radical 32 times 6 over radical 6 times radical 6. and that just equals 6, like in the denominator. So now my denominator doesn't have a radical, which was my goal.
I don't understand what you did.
You don't understand? Okay. So which part do you not understand?
How you got from radical 32 over radical 6, radical 32 times 6 over 6, radical 6 times 6.
So like how I got this fraction or how I multiplied them together?
How you got that?
Oh, how I got this? No, I'll explain that in just a second after I finish like simplifying this. So after I get this, I just simplify at the top 2 in order to get 8 radical 3 over 6, but I also have to cross these out since it's not completely simplified yet. And then I finally get my answer of 4 radical 3 over 3. Now, so somebody asked a very good question. So how do I know like to multiply by this specific number? Well, the answer to that is I'm going to try and get rid of this radical, right? And if I multiply like by, I don't know, radical 2 over 2, that's also multiplying by 1, so it doesn't do anything to my number, but it also doesn't help me because then my denominator just becomes radical 12. And even if I simplify it and take out like a 4, I'm still gonna have a radical, which isn't good for me. I don't want that there. So if I want to get rid of this radical, like if I multiply this number by itself, I know that it's gonna become the number that's inside the radical. Because like this is the square root, right? If I multiply the square root of a number by the square root of a number, then it equals that number. So that's like the easiest way to get rid of my radical. So that's why I multiply my initial fraction with a fraction that equals 1, which has the denominator as both the numerator and the denominator, so that I can get rid of the radical in the bottom. Does that make sense?
No, I still don't understand it.
Amy,
Think
do you
about
want
it.
to
Yeah, maybe I could try to explain. So,
you want remote control or no?
no, it's okay. I can just explain it verbally, and you can like maybe draw on it.
Yeah.
So like our fraction is like the square root of 32 over the square root of 6, but we don't want the square root of 6 in the denominator. So, well, specifically, we just don't want the square root in the denominator. But here's the thing: when you square root a perfect square, the square root goes away and it just becomes a number, right? So if we can multiply the denominator by itself, then we get a square root and the radical goes away, right? So square root of 6 is in the denominator, but if we multiply the denominator by square root of 6 again, it becomes the square root of 36, which just simplifies down to a regular 6. So the radical goes away. That's the whole reason why we want to multiply. That's how we get rid of like radicals in the denominator. But the problem is that we can't just multiply by square root of 6 in the denominator, because then that changes the fraction, and after we multiply, it's not the same fraction anymore. However, what we can do is multiply by 1, since multiplying by 1 doesn't change anything. So if we write the square root of 6 over the square root of 6, like just focusing on this fraction, the square root of 6 divided by the square root of 6, that equals 1, because a number divided by itself is just 1. So if we multiply our fraction by that number, then it doesn't change the fraction because we're just multiplying by 1. But at the same time, it makes it so that the denominator becomes, the denominator gets rid of the square root, and it fixes our problem of getting rid of the square root from the denominator. Does that make more sense?
So square root 6 times square root 6 equals 6?
Mm-hmm.
Yeah.
Okay. Oh yeah, I understand now.
Okay, that's great. So thank you for asking questions, guys. So let's move on to the next.
Okay, so how did you get? Oh no, mine just simplified.
Wait, what did you say?
I was just wondering for the second part of it, after 32 times 6.
I think he's
Oh.
asking how you simplified it.
Oh, okay. So like how I went from this to this?
Yeah.
Okay. So we actually didn't like write out everything, but basically like if I multiply 32 times 6, so under the radical, I'm gonna have, okay, I guess I'll multiply it all. So 192, right? And if I want to divide this, I want to make this so that I can simplify it. So remember when we did square root of 24, I made this into the square root of 4 times the square root of 6, because so I can simplify this to a 2. I'm going to try to do that with this 192 too. And I can see that maybe it's not like directly obvious at first, but I can see that 192 is 64 times 3. 192 is also 32 times 6, but this doesn't help me because neither of these can be simplified into a whole number. But if I make it like this, then I can simplify the square root of 64 into 8. So then I basically take out 64, like here. I make it like this. And then this also equals the square root of 64 times the square root of 3, which equals 8 times the square root of 3.
Okay, got it.
Okay, that's great. So somebody said they're confused. Are you confused about what I just explained? Or how to simplify? Do you want to explain, Amy? I don't know if I can explain it like differently.
Okay, I can explain. So what Kayang just explained was how to simplify the top of the fraction. So specifically, Kayang, you can circle it, the square root of 32 times 6. So we're just focusing on that part. So this would simplify to 8 square root of 3, but Kayang's walking through how we get there. So when you simplify a radical, you want to get rid of any perfect squares under the radical. So the square root of 32 times 6, if you just multiply 32 times 6, that equals 192, right? So the square root of 32 times 6 is equal to the square root of 192. 92 has a perfect square. 92 is equal to 64 times 3, or 192 equals 64 times 3. So when we're simplifying, we want to get rid of any perfect squares. And since 64 is a perfect square, we basically rewrite the radical. So square root of 192 equals the square root of 64 times the square root of 3. So essentially, it's just the same thing. It's just that we're writing it in radical form. So square root equals the square root of 64 times the square root of 3. But since we know since the square root of 64 is 8, we can just simplify that to 8. So it becomes 8 times the square root of 3. And that's it. You can't go any further because you can't really simplify 3 into square roots without getting into some weird numbers. Yeah. So we just, yeah, that's good.
That's great. Yeah. Okay, I'm going to clear the board. All right, any other questions before we move on? Okay, we're going to move on then.
I think we can skip the Jamboard because I'm pretty sure we don't have time.
Yeah, we'll have time. So
Okay.
This, you can look at this on your own time again. This is just like practice but right now, because class ends at 4:30 and we only have 5 minutes, we're going to skip it. So I guess I can go over these. And we're gonna go over it kind of quickly. So this isn't any like specifically math, like completely math. This is just 5 mistakes you should know to avoid in general. So the first one is don't mix up which terms are under the radical and which aren't. So what this means is like this one, these two are two separate numbers, right? And this one is just, the second one is just a 2, and the first one is radical 6. But this might also, you might also think it's actually this, which is this, and that's different from what this actually means, which is 2 radical 6. So it's just basically telling you to look carefully and write things in the correct format if possible. And you might not like understand all of these right now, and that's okay since we haven't gone over that much, but you could, some of you know more than others, and it will be handy in the future. So the second one just tells you that the square root of a plus b does not equal the square root of a plus the square root of b. Instead, the square root of a times b is equal to square root of a plus square root of b. But a lot of people get confused like this. Number 3 is kind of similar. The quantity of a plus b squared does not equal a squared plus b squared. It actually equals a squared plus 2ab plus b squared. We haven't gone over this, so this one you can just disregard if you don't understand. Number 4, if you're solving the equation x squared equals 4, the answer can be either 2 or negative 2. Since 2 squared is negative 4, and negative 2 squared is also 4. But when we're looking for the square root, like using this radical symbol, always just give the positive answer. So don't worry about the negative when you're solving for square roots. And finally, negative exponents don't result in your answer being negative. Remember, like 2 to the negative 2, this doesn't mean it's gonna be like negative 4. It just means it's gonna be 1 over 4. So yeah, those are just things to keep in mind. And finally, we are going to go to our last slide for today, which is homework. So
yeah, I can talk about the homework. So as we previously mentioned, homework is just going to be through quizzes. Also, I think we spelled quizzes with the wrong number of C's, but okay. It's just going to be through quizzes assignment. If you've never used quizzes before, you just yeah, they should have 2 Z's at the end, not 2 Z's in the middle. But quizzes is just like Kahoot. Well, it's not just like Kahoot. It's similar to Kahoot, but it's like not like synchronous. It's not like we're not all doing it at the same time. You can do it like individually, but it does have like rankings, and it also gives you like these weird power-up things, which aren't always helpful, but I guess it makes
you'll
it more
see,
fun.
it'll walk you through. It's more fun than just like
Yeah.
a normal Google form or something.
Yeah, and it also lets you but quizzes also lets you retry questions that you missed and get points for those. So it will just probably be posted on Google Classroom sometime today or tomorrow, and we're gonna probably make it due like 3 p.m. next Saturday. And then also when you're like doing the Kahoot, include your actual name somewhere where when it asks you, hey, type in your nickname, you should probably include your actual name somewhere on it. Otherwise, we can't give you any points for your rankings. So yeah, the links on the slides. So probably we'll post the slides and the homework thing later. So yeah.
The classroom.
Oh, are you on the classroom?
Wait, how did you
get? Oh no, this will not be a grade for your report cards. this is just gonna be like a thing to like help you guys learn. I mean, none of this is like an actual like formal class for any grade or anything. No, don't. It's not like that. That'd be pretty crazy. Like this is like hard stuff, and like I mean, it's mostly just about you guys like learning. Like it doesn't matter where you guys start off. It's more about like where you guys get to. So yeah.
We're not like associated with Mizik or something. We're just like our own separate thing, helping you guys learn.
Yeah.
Somebody asked, oh, by the way, we are done for today. So if you don't have any like individual questions, you can leave. And I think it was Braden and Tanisha.
Yeah.
You guys, if you could stay after for like 2 seconds, that'd be great.
Also, Kyung, I think you can stop recording now.
Okay, yeah.
Thank you guys. Oh, thank you guys for coming. And also, we'll be going over more stuff in the future weeks about like more cool topics. And yeah, maybe this class may have been a little boring for some of you guys, or it might have been a little bit too hard for some of you guys. We'll be talking about some other stuff in the next few classes.
I don't know. Oh, I was here.
Wait, Kyung, did you stop recording?
How do we get to